Hello everyone, welcome to my channel. Guys, today I'm going to show how to deal with how to do calculation about subtraction in microcontroller 8051. For you to be able to understand how to solve question about subtraction or to show calculation about subtraction in microcontroller 8051, which is chapter 6. I'm on page 127. I hope you know the book, the microcontroller 8051. I'm on page 27. So you must understand these three steps. The first step, they say take the second complement of the source operand or the substrate. You add that second complement to your accumulator, and then at the end you invert the carry. So this is English, this is how they explain in English, but how does it work exactly? How we do this calculation? For some it may be easy to understand fast, but for others I need to explain, because there's some terms like source operand, there's accumulator, and then they say invert the carry. So people will ask themselves the question, what's the carry? What are we talking about? So I'm going to take this example here on question number 5, and I'm going to explain this example. So I pick, they say the first line, they say clear accumulator, which means accumulator is equal to 0. So let's go first to the board. I'm doing this example. If you have the book at the same time, you can follow me using your book also, so that you can understand better. Let's go back there on the board. This is the line of code. The first line, they say clear the accumulator. So when we clear the carry, so which means the carry here CY is equal to 0, or AC, which is also a carry, we clean it, which is equal to 0. So the second line, they say move the value of 3F in the accumulator. So if you move the value of 3F in the accumulator, which means accumulator has a value now of 3F inside H. So they say the third line, they say what? They say move the value of 23 in R3. So R3 will be equal to 23 in hexadecimal. And then the last line, they say subtract accumulator and R3. The thing that I'm going to remind you again, the register must be here next to the subtraction instruction or add instruction. Remember, it must always be the accumulator. If you put R3 before, if you put R3 here, it's gonna be a mistake. Let's say if you write sub and then you say R3 and then A, it's gonna be wrong, because the resistor that must be here must be the accumulator. It's the only accumulator that is able to perform subtraction or arithmetics operations, only the accumulator. The R3, this register from R0 to R7, they can only store information, they can't do subtraction and everything. So you must make sure that resistor must be the accumulator. But the fact is the accumulator, we call this resistor here. Now this is a destination resistor. Destination register. Destination. So the R3, sorry, this is what we call your source register or source operand. That's how they say here. Source, they call it source operand or substrate. So let's go back now here. They say what? Let's calculate here. So which mean in this line, what did they say? They say which means this line is like accumulator is equal to 3F, which is inside the accumulator, and then they say they subtract that 3F, sorry, which 23. Obvious, if you use your calculator, the result will be 1C. But this is cool. When you're using your calculator, they will ask you what's the final result. You say it's 1C. But the question may be difficult for you if they say what's the value of the carry, or what, show us the calculation that may be a problem if you don't understand how does it work, how this subtraction operation work in the microcontroller 8051. So I'm going to show you how this thing works. So I will write on the other side. Let me pick the green pen. So we're going to have 3F in binary, which is 0 0 0, and sorry, which is 0 in binary, which is 0. Sorry, it's the 3F 1 1, and then we're going to have F F F F, which is 1 1 1 1 4 1, and then let's say you must add the source. You must add this value, your destination operand. You must add it with, let's go back to the book, with you must add with the second complement of the source operand. So the second complement here in our case is 20. The source operand here is 23. So that 23, we must take the second complement of 23. So let's convert first to, it's gonna be what, 0 0 1 and 0, and then we're going to have 0 0 and 1 1. So they say you must take the second complement of this number, which is 23, and then you add it with the first complement. So what's the second complement of 23? So before we go to second complement, we must first write the first complement. So the first complement we only invert. So 1 change to 0, 1 change to 0, 0 change to 1, 1, and then 1, and then 0, and then 1, and then 1. So this is our first complement. So the second complement, we add 1 to this side only. We add, so let me erase that side because it may be it may confuse other student. So yeah, this one we done already because we changed this one, sorry. And then we're going to have 1 0 1 1, and then 1 0 1 1. So this is the second complement. Let me use another pen. So this is the second complement of 23. So we're going to add it with the destination operand. So we're going to have 1 1 0 1, and then 1 1 0 1. So we're going to add here. So to add here, when you have 1 1, it's gonna give us what? 0. It's gonna give us 0. It's gonna give us 1. It's gonna give us 1. But the fact, like we have a carry here, because we're going to have a carry after adding 1 1, we're going to have a carry here. That carry that will come in this side. The fact this carry from D7, because this line, this bit is D0 bit, and this bit here is D7. So we discussed about this AC previously. So the AC is the carry that moves from this side and comes to this side. So this carry, we call it is the AC carry. So that AC, in our calculation, that AC is equal to 1, but you must change that AC to 0. So after that, we have that carry comes here, give us 1, and then we're going to have 0 0 0, and then we have a carry that comes here that we call another carry, which is a CY. So that carry CY, the carry at D7, it's CY, so it's equal to 1, but you must change it to 0, vice versa. If it's 0, you change to 1. If it's 0, you change to 1, or if it's 1, you change to 0. That's how we change the carry. So this is the result. So at the end, the result here, we got 1. We change that carry, the carry, to 0. So this is the final result. This is the final result. Let me erase down here. This is the final result. So we're going to have the final result is 0 0 1, and then 1 1 0 0. So here, if you convert this one in hexadecimal, it's C, and then if you convert this one is 1, because this one gives us 12. We're going to have 8 and 4, 12, and then here we have only 1, so 1C. This is the result that we got here. But now if they ask you a question, show the calculation, you show the calculation which is right, so which means you understand. And then if they say give the value of the carry, the value AC, for AC is going to equal to 0, and for CY is going to equal to 1 to 0, sorry. This is the final result. Let me erase here. Final result. Let me erase here, and so this is the final result. So the final result is 1C. The carry, its AC is equal to 0, CY equal to 0. Let's go back to the book. This is what is here down. So I hope you understand how to do subtraction in microcontroller 8051. So thank you, and don't forget to subscribe, and then I'll see you in another video where I'm going to explain something else, maybe I think multiplication. Sharp, thank you, and see you in the next video.